The name of the second
Yes,
chapter
sir.
is whole numbers. Chapter, these are the basic concepts which are mentioned. First, we are going to learn the definition part of whole numbers, and we also will learn how to represent a whole number, followed by properties of whole numbers. In that, the first property is closure property, second property is commutative property, the third property is associative property, fourth one is distributive property. Then we will learn the meaning of additive identity and multiplicative identity, followed by multiplication by 0 and division by 0, which is not defined. We are going to learn these important concepts. To begin with, we will define whole numbers. We all have learned that counting numbers are called as natural numbers. The numbers 1, 2, 3, and so on. They are natural numbers or counting numbers. Now, let us add one more number, that is 0, to the collection of natural numbers. Now the numbers will become 0, 1, 2, so on. These numbers are called as whole numbers. We can say that whole numbers consist of 0 and all the natural numbers. Therefore, except 0, all the whole numbers are natural numbers. We will learn to represent the set of whole numbers. If you remember, the set of natural numbers, we denoted it by letter n, and we wrote 1, 2, 3, and so on. Here, the set of natural numbers are represented using the letter n. The letter W in capital letter is used for the set of whole numbers. It will start from 0, 1, 2, 3, and so on. Or I can also represent the set of whole numbers as 0 along with the set of natural numbers. Hope this is clear to you. Now if I ask you a question that which set among natural numbers and whole numbers is larger set?
Whole number.
Whole number.
Whole number. Sir.
Whole number.
Sir, both are equal.
Whole number.
Sir, both are
Whole
equal.
number set.
Whole number.
Sir, no, sir. Whole numbers are bigger
Both are not
because
equal. The set of
whole
whole
number
numbers
begins
is a
from
larger set because it contains one element more than the set of natural numbers. We can say that
Yes,
the
sir.
set of natural numbers are present in
In whole numbers.
whole numbers. Can we say the reverse? Set of whole numbers present in natural numbers?
No, sir.
No, we should not say that because 0 is not present in the set of
Not present in
natural
natural numbers.
numbers. We represent it like this: N
Good morning, sir.
C W. What is the meaning of N C W? It means that natural numbers are contained in whole numbers. Contained in. If you want to read it in this direction, it is whole numbers contains natural numbers. If you read in this direction, natural numbers are contained in whole numbers. That is the reason why the set of whole numbers is a larger set compared to the set of natural numbers. Now, there are certain facts you must know related to whole numbers. The first fact is the smallest natural number is 1. This 1 is also a whole number, but the smallest natural number is 1. And the smallest whole number is 0. This 0 is the first whole number and it is the smallest whole number. There are infinitely many or uncountable number of whole numbers. It means that the set of whole numbers is an infinite set. So I will write it here. Whole numbers are infinite set. All the whole numbers, they contain natural numbers. So I can say that all natural numbers are whole numbers. All whole numbers are not natural numbers. For example, 0 is a whole number. It is not a natural number. These are certain facts you must know related to whole numbers. Now look at this slide. Here I have mentioned successor and predecessor. We know the meaning of successor. Successor means the next number. Successor of a whole number is the number obtained by adding 1. Like natural numbers, each time we add 1, we get the successor. Each time we subtract 1, we get the predecessor. Predecessor of a whole number is 1 less than the given number. Look at the successor clearly. The successor of 1 is 2, the successor of 2 is 3, successor of 3 is 4, and so on. Same way, predecessor of 1 is 0, predecessor of 2 is 1, predecessor of 3 is 2, and so on. The whole number 0 doesn't have any predecessor. Here is a question. Please look at the slide here. You need to write the successor of these numbers. You must know that the successor is obtained by adding 1. So add 1 to this. The successor becomes 1070110702. Now, in a rough, you write the answer. I'll be asking you. I'll be asking you the answer for the second one. Prithvi, Gururaj, your answers are correct. The answer for this is 1004991000500. The successor of this particular number is 5099999. How many times 9 are there? 1, 2, 3, 4, 5 times 9 are there. Followed by 5. This becomes 1 followed by 5 zeros. Yes, Nitin, Prithvi, Tarun, your answers are correct. Tanmay, your answer is right. So this is how we write successor. The successor of this particular number is 56705671. Likewise, by subtracting 1, we do get predecessor. To find predecessor of 1414, you need to subtract 1. It becomes 1413. Now, little tricky. This particular number, how do we write the predecessor? If you subtract 1, what will be this? One followed by 5 zeros, then 0 followed by 5 nines. Correct. Mini, right. Parth, right. This particular number C, 80908090, this becomes 80908089. Good. Tanmay, Ishan, Gururaj, your answers are correct. Now the last one, D, the predecessor of 4321 4321 is 4321 4320. Ishan, Pritham, Gurraj, Sudhindra, your answers are right. This is how we write predecessor and successor. Now we will learn very important concept which are called as properties of whole numbers. The first property of whole number is called as a closure property. Suppose if I consider a number say 2 and add another number say 1, the sum becomes 3. 2 is a whole number, 1 is a whole number, the sum is also a whole number. Here, observe carefully. I have written plus sign. It means I am adding the numbers. So whenever addition is taken, the sum of two numbers is a whole number. Sum of two whole numbers is again a whole number. This property is called as closure property under addition. This first one is under addition. So how do we define this? We define like sum of any two whole numbers is a whole number. Suppose if I consider A as a whole number and add another whole number, say B, we get a whole number C. We can also change the order of addition. The sum remains same. Here 1 added to 2, we get the same sum. This is true for any two whole numbers. Any two whole numbers, you add them, we get a whole number again. This particular property is called as closure property under addition. Can we say that closure property under subtraction is true? If you consider a number say 2 and subtract 1, we'll be getting 1. Whereas 1 minus 2, we do not get 1. And also, if you do 3 minus 4, we will be getting minus 1 is not a whole number. So closure property is not true in the case of subtraction. Because every time we are not going to get a whole number. Is it true in the case of multiplication? Suppose if I consider two whole numbers and multiply them, do we get the product as a whole number? Randomly, if I take 3 as a whole number and I'll multiply 4, the product is 12. So it means that the product of any two whole numbers, is a whole number. Is this true in all the cases? Suppose if I take 5 multiplied to 0, we get the product as 0. 5 is a whole number, 0 is a whole number, their product is also a whole number. This particular thing is true if the order of multiplication is changed. If 0 is multiplied to 5, we do get 0 only. Same way, 4 multiplied to 3, we get 12. In general, A multiplied to B, we get C. This is equal to B multiplied to A. So, the set of whole numbers, the multiplication is closed. We say that the multiplication is closed in case of whole numbers. So whole numbers are closed under multiplication. Is it true in the case of division? Suppose if I consider 1 and divide by 2, I'll be getting 1 by 2. This is a fraction. It is not a whole number. So this means that the set of whole numbers, are closed under addition and multiplication only. So I can also say that the set of whole numbers are not closed under division and subtraction. Hope all of you have understood this.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So I am writing a summary of
Will you
the
send
first
this in our
property.
WhatsApp?
I will send
Yes,
it in your WhatsApp. I am writing the summary here. The summary is A added to B, we get C. This is equal
Okay,
to
sir.
B
To B
added
plus
to
A.
A. The second one, A multiplied to
A
B is C, which is equal to B into
B
A.
multiplied
B
by A.
multiplies C. A plus B
Here,
is
A, B, and C are whole numbers.
Yes.
So this property is called as a closure property. This is a first property. The second property is called as commutative property. Or it is also called as commutativity. If I say that I have got 10 rupees with me and Sudhindra has got 5 rupees with him, together we have 15 rupees.
Sir,
If I change the order,
sir,
yes,
please tell him.
please tell it in Hindi.
Sir, please tell. Yes, sir.
If I have 10 chocolates with me, Vinny, you have 5 chocolates with you. Together, the number of chocolates with us
Yes, sir.
is 15.
50.
है ना? है ना? If
Yes, sir.
I do
Yes,
this,
sir.
5 plus 10,
15,
still
sir.
15 only.
15, sir. Yes, sir. 15,
So look at the order.
15, 15, sir.
Though the order of addition is changed, the sum remains the same. The same is true in case of multiplication. 5 multiplied to 10, we get 50.
50.
If 10 is multiplied to 5, still we get 50.
50, sir.
So the order
Order.
doesn't
Order, sir.
change sum or the product. If I say that 10 divided by 2, we get 5. But
Sir.
yes, 2 divided by 10
2
is
divided
not
by
equal to 5.
0.2.
Not correct.
It is not equal to 5.
Sir, I have a doubt.
sir.
It does not have
If
commutative
I
property.
consider 10 minus
Sir.
5, we get 5. 5
Sir, I
minus
have.
10 is not equal to 5.
Yes, sir.
Yes,
Yes.
Minus 5.
So, commutative
Sir.
property is true in case of addition and multiplication. It is not true in the case of division and subtraction.
Yes, sir. Yes, sir. Okay, sir.
In general, if I write
Sir.
a plus b,
Sir, I
this
have
is
a
equal
doubt,
to
sir.
b plus a. A into b is equal to b into a.
I have.
This property is called as commutative property or commutativity. Now you can ask your doubt. Yes.
Sir.
Varun is asking doubt. Yes, Varun.
Sir, commutative property is closed under addition and multiplication only, sir.
Yes, it is not true for division and subtraction. Yes, any other doubt?
Sir.
Sir. Do
Yes.
commutative property work in three numbers?
Commutative property work in the three number, and that particular property we call it as associativity. It is called as associative property, which is the next
sir.
property, third one.
What, sir?
Subtraction and division not
Yes, commutativity is
not
not there.
commutative, sir.
Commutative property is not there, or it is not true in case of subtraction and division.
And division.
It is true only in addition and multiplication. Now suppose if three whole numbers are there, 5, 1 and 4. If I do addition of these two, then add this with 5, I will be getting 5 plus 5, which is 10.
10, sir.
If I
Yes,
consider
sir.
it like this, 5 plus 1,
10 is the answer.
for
Plus
this
4
also,
is equal to 10.
6 plus 4 is 10.
10.
Sir.
10, sir.
So I can say that these two are equal.
10. Yes, sir.
5 plus 1 plus
Yes,
4
sir.
is same as 5 plus 1 added to 4.
Yes, sir. Yes, sir.
हम
Yes,
लोगों को
sir.
पता है we have to use
Yes, sir.
Bodmer's rule. Bracket has to be simplified first, then addition should be done. So whenever A is added to the sum of B and C, the sum of A and B added to C will give the same result. And this property is called as associative property. Associative.
Okay, sir. Associative property.
So this is second property.
This is third property.
Third
my dear.
property.
First property was closure property. Second property is commutative property.
Commutative
And the
property.
third one is associative.
Associative.
Associative property.
Associative property.
Associative
Property.
Hello,
In
sir.
the
Explain me
associative
1 second, sir.
property, in the associative property, addition, it is true. We have checked. Is it true for multiplication? Let's see. 5 multiplied to, within the bracket, I will write 1 into 4. What result we get?
30.
5 times of, this will be 4, 20.
20.
Not 30, it is 20.
Sir.
20.
Okay,
Sir, it
somebody
is
else?
true, sir.
Yes, it is true.
Sir, it's true, sir.
Sir, it is not true, sir.
Correct, sir?
Is it
5
it is like
multiplied to
question is closed under
multiplied to
5
4.
into 1 into 4 is equal to 20.
We get the same result.
Which is the second
So I should write 5 times of 1 into 4 is equal to 5 times of 1 multiplied to 4. Once again, I'll tell,
Yes, sir.
whenever we have 3 different numbers, say A, B, C, if I do the sum of B plus C added to A, we get the same result when A plus B is added to
B
C.
is equal to Sir, multiplication is closed under associative property, sir.
We should not say like that. We have to say that whole numbers are whole numbers are true in case of, sorry, associative property is true in case of addition. Associative property is true in case of multiplication. We have to say like that.
Okay, sir.
Okay, sir.
I will write it here. The set
sir.
of whole numbers.
Okay, sir. Sir, which is the second property, sir?
I will tell. I will get back to you. Set of whole numbers are associative.
Which is the first property, sir?
I will get back to you.
Subtraction, then will your answer come same only, sir.
Papa.
If you do
Something
division and subtraction, you will not get the same result. This is the third property, which is called as associative property. The first, I have totally discussed 3 properties. The first one is closure.
Closure property.
The second one is commutative.
Commutative.
And the third one is associative.
Associative. Associative property.
So these 3 properties we have learned now. And these 3 are true in case of addition and multiplication only.
Multiplication. Sir, these 3 we should write in notebook, sir.
I will give you the notes. Now I will tell another important property. This is the last property for today's session.
Sir, in
Whenever we
WhatsApp
have,
group, sir.
yes sir, 5 multiplied to 6 plus 2.
WhatsApp group, sir.
Look at this. 5 multiplied to 6 plus 2.
Sir,
Property is called
This will
40,
be
sir.
5
This
times
is
of
answer is
6
40, sir.
plus 5
Answer is
times of
40,
2.
sir. Answer is 40, sir.
answer is 40.
Answer is 40.
Answer is 40.
Yes, you are all right.
40.
Here, what did I do? I have multiplied to both 6 as well as 2. This property is called as distributive property.
Distributive property, sir.
Distributive property, sir.
Why it is called as a distributive property? We are distributing the multiplication to both the
Please
numbers.
tell in Kannada, sir.
Aniket,
Distributed 5 to each number, sir.
Aniket, 5 is multiplied to 6. 5 is also multiplied to 2. So I have distributed the multiplication over addition. This is called as distributive property of multiplication over addition. हिंदी में डिस्ट्रीब्यूटिव प्रॉपर्टी को क्या बोलते हैं? आई हैव नो क्लू. ओके सर, हम क्या कर रहे हैं सिर्फ मैं बता सकता हूँ. 5 इज मल्टीप्लाई टू 6. 5 को हम 6 के साथ मल्टीप्लाई कर रहे हैं. 5 को हम 2 के साथ भी मल्टीप्लाई कर रहे हैं.
सर इंग्लिश में बोलिए, हिंदी समझ में नहीं आ रहा है.
You have joined an English medium school, my dear. You have to learn in English only. Whatever the class we do record it, and it is there in the YouTube, and it is accessible to everyone.
Sir, I am not
Should
able
speak
to
English.
Didn't get it, sir.
on YouTube of science.
Sir, we didn't get the video,
Sir,
sir,
can
in
you
YouTube.
give the YouTube channel, sir?
Still only in
Tell me
English.
YouTube channel name, sir.
I will tell it. If you log in ssbj.in, you will get a page. The best thing is I will show it. I will show you.
Reopening, sir.
Wait for a while. I will show.
Sir, where is your video download?
Now all of you are able to see the Google here.
Sir,
Yes, sir.
Yes. Suppose if I type
Sir,
here ssbj.in,
No, sir.
ssbj.in,
Yes, sir.
No,
Yes,
sir.
there is a
Sir.
Sir.
see, sir.
Yes, sir.
Sir.
sir, I
Yes,
have.
sir, it came, sir.
Yes, sir. It came,
Sir,
sir.
it
Yes,
is
sir.
there, sir.
yes.
Yes, sir.
Yes,
Sir,
sir.
Sir, my